This tutorial will provide you information on how to perform some simple signal measurements in PoScope 4 software. For this purpose, we made a simple circuit that consists of 9-volt battery, 470 microfarad electrolytic capacitor, 10 kilo-ohm resistor and a single-pole double-throw switch. The battery will charge the capacitor until the capacitor voltage gets close to the battery voltage. As we press the switch, the capacitor charge will discharge over resistor towards ground. When we release the switch, the capacitor will begin to charge again, and so on. Let's take a look. We have a PoScope Mega 1 oscilloscope plugged to a USB port. Its probes are connected to a positive and a negative pole of a capacitor, ground. Let's see what's going on. Click on the PoScope Mega 1 device to open its control and on oscilloscope display to view the signal. Now we have to adjust the oscilloscope settings to view the signal properly. We will be observing signal no higher than 9 volts, so we can set it to 10 volts. We will observe AC component of a signal, so we can cut out the DC component of a signal. We will be measuring only one signal, so we can turn the channel B off. The capacitor is now charged, so let's try to discharge it using a switch. We can clearly see the voltage decreases according to expected exponential decay. Let's adjust time base a bit, so we can see this more clearly. Use the slider under axis, slide it to your right and observe how the waveform changes. Now let's adjust sampling frequency. That resets the time-based setting, so we have to adjust it again. Move the slider to the right and follow how the signal waveform becomes more clear. We can see how the capacitor is charging and discharging over a longer time base. The waveform appears a bit fuzzy, so let's correct that too. Just use the resolution switch on the Mega 1 controls plugin. Switch it to 12 bits, adjust the time base and see how the signal appears to be nice and smooth. PoScope software offers you a wide range of tools. For amplitudes and timing purposes, you can use two vertical cursors, C1 and C2, which shows you signal parameters. We will drag C1 to this line and C2 to the next. Here we can clearly see how the capacitor is charging close to the battery voltage. The battery isn't completely full and discharging close to 0 volts. We notice this occurs at 60 and 80 seconds, making the difference between them 20 seconds. If needed, we can freely move the waveform up and down. Just use the Move function found under Move Signal drop-down menu. This comes handy when we simultaneously observe different signals on the same display and we don't want them to cover each other. To automatically move the signal waveform to zero line or x-axis of oscilloscope display, use the Auto Scale command. Auto Zero command eliminates offset voltages from signal. Auto Scale command adjusts vertical scale to show full signal on the display. Volts per division setting is also shown on the oscilloscope display. It says 2 volts per division. We have 1, 2, 3, 4 divisions, and 2 by 4 equals 8, so we have approximately 8 volt signal. For amplitude and timing purposes, we can also use the data table, which shows the relationships between parameters of the two cursors. When measuring fast signals, you can catch signal conditions with the PoScope's advanced triggering function. Just turn on triggering, select source channel, set mode and the desired edge of the signal. You can even drag the horizontal and vertical cursor anywhere you want and, in our case, the rising signal waveform will appear at this point. If you want to closely examine any part of a signal waveform, you can use the zoom function. To zoom in, left-click to upper left corner of an area you want to examine and drag your mouse to the lower right corner of that area. To zoom out, you have to do the exact opposite. Left-click on the lower right corner and drag the mouse up to the upper left corner of that area. This concludes this basic tutorial. We learned how to use the oscilloscope with its basic functions. For more advanced use of Mega One device, move on to the next exercise. Thanks for watching.